Next up, I'm gonna show you how to solve the ALEKS problem, rank the intermolecular forces. Again, for organic chemistry, we're still going through these steps of we're introducing new material, of course, with the functional groups, but we're still at a part where we're kind of tying in some stuff we learned from Gen Chem as well. So my tips to solve this one is refresh yourself on intermolecular forces from Gen Chem 2. Look for the more polar electronegative atoms. Look for hydrogen bonding. And remember, it only happens if hydrogen is attached to oxygen, nitrogen, or fluorine. And then longer compounds have stronger intermolecular forces. So right here below, I wrote kind of the chart for from weakest or from strongest to weakest intermolecular force, and we'll see what we have here. So looking at these, we'll start with this top four. Looking at it, we see we have no metals involved, so I could X out, it'll be no ionic or metallic bond in there. So next up, I'm going to look for my polar. So I see that I have oxygen here and I have an oxygen here. So I know that at least my top two are going to be, or my top two strongest are going to be these two. Next, I try to see what's the difference between them, and I'm going to see if any of them hydrogen bonds. So in this case, I have an oxygen, which is going to be attached onto this carbon and this carbon. So no hydrogen bond in there. But right here, I have an oxygen that's attached onto a hydrogen right here, along with being attached onto a carbon. So it does have hydrogen bonding. So I'll rank this one as number 4 because it's the strongest. And then because this is polar and these other two right here, the top one and this one are not polar, I'm going to say that this one right here ranks number 3 as the second strongest. And then I want to focus on these two. Both of them are van der Waals, so they're not polar. So kind of the next rule that we follow is that longer compounds have stronger intermolecular forces because it goes kind of out straighter, kind of more stronger and less to kind of pull in. So we'll rank this one as number 2 because this is a longer carbon chain than what this one is. And then this will be ranked last. So in order, we got 1, 2, 3, 4. And then I'll solve another one real quick using that same system. So first I'll look for polar or hydrogen bonding. I see right now that I only have one. Well, I have two that'll be polar. This chlorine to this methyl right here and this oxygen to this methyl. So what I want to see is which one is either more electronegative or hydrogen bonding. So I'll start with looking for a hydrogen bond first. So I see that in this compound right here, I have this oxygen, which is attached on to a hydrogen here. So that'll be ranked number 4. So that'll be my strongest. And then because this is dipole, and these other two compounds right here, this methyl and this methyl, two methyls right here are not as polar. So I'm going to rank CH or this methyl chlorine as number 3. And then I look at my other two and I follow my last rule, which one is longer. So the one that's creating the longer chain is going to be the one with these two carbons right here. So this is going to be ranked number 2. And this is going to be ranked number 1. Again, fairly simple material. Just ensure that you follow the steps and tips and refresh yourself on intermolecular forces, and you'll be all right for this one. If this helped you or your classmates, feel free to like, share, and subscribe to my channel. Thank you.